least. This recording is always so strange. It takes a minute or two to kick in. Okay, cool. So basically what we're going to talk about today is something that's at a level quite self-explanatory, right? Self-explanatory in the sense that the concepts are easy to understand. The bright side is you don't actually have to remember them. And I say this because your guys' exam is a take-home exam. But we are going to go through the concepts in more or less detail. We're going to talk about risk and business continuity. Now, risks are undesirable events that occur. Business continuity means that when a risk happens or when a threat actually happens and your systems get hacked and go down, how do I then continue while I'm fixing my problem? So basically, they say this in your textbook. Business continuity is basically an organization's ability to maintain operations after a disruptive event. So after your systems are hacked, after a catastrophe, it might not even be cybercrime related. It might be that there was a flood or a hurricane or some natural disaster that basically didn't allow your business to function. Anything that disrupts the normal functioning. And you have to always be prepared. And there are 3 steps to being prepared. And this is business continuity planning, impact analysis, and disaster recovery planning. Now, business continuity planning looks at identifying exposure to threats. So what could possibly be threats that my business can be exposed to? And it creates preventative and recovery procedures. And of course, you have to test them to determine that they are sufficient. So there are 3 essential elements here: business recovery planning, crisis management and communications, and disaster recovery. Business impact analysis identifies business functions and basically gives them certain levels and quantifies the impact of loss that these functions may have on business operations. So if we have to take an example of this, if we have to look at a website like Takealot, if the payment facility had to go down, that's one of the core business functionalities. If your payment system is not working, you are not going to be able to have customers pay for their products, which can definitely impact in terms of the business suffering a loss. So as I say, that's one example, but there are various types of threats, and these range from impacts on property, that's your actual physical assets, your impact on your finance, monetary funding, impact on the safety, of course, physical protection, impact on reputation, and impact on life or well-being. So a business impact analysis will help determine mission essential functions. And that's activities that serve core purposes of the enterprise. If we have to take another example of this, if you have to look at an aeroplane, right, or your air traffic controller, those air traffic control systems, they are safety critical systems. Because, of course, if they get information wrong, or if they report the wrong information to your air carrier, that can result in possible loss of life. So that impact would, of course, be huge, or the biggest, because it's an impact on life. So BIA can help in identification of critical systems, and these are systems that support mission essential functions. And one of the key things here is to identify single points of failure. So you don't want to have single points of failure, are probably the worst things that you can have in any system, guys, even your own system. So it's basically a component or entity which can disable the entire system. So basically your runtime error, debug, complete system failure, that point where your system can completely fail. You need to identify these, okay, and you have to minimize them because you always want your system to always be available and running. So yeah, many business impact analysis also contain privacy impact analysis, and these are used to identify and mitigate privacy risks. And there's also privacy threshold assessments can determine if a system contains personally identifiable information. Okay, so this would be your credit card information. So this would be, of course, a big issue if, of course, somebody can get information like credit card information, your name, your surname, your ID number. So that, of course, is quite an issue. And you've got disaster recovery plan. And this is when there's a complete disaster that makes your system go down, and you have to think of how you are going to plan around this. So it focuses on protecting and restoring information technology functions. And this is a document that details what's going to happen when a disruptive event occurs. So it has to be comprehensive. It has to have a set of features. You have to cover specific topics, and it requires testing for verification. So in terms of your disaster recovery plan, this is what it's basically made up of. Your purpose and your scope. Why do I have this plan? How much of the organization am I looking at in terms of the scope? Am I just looking at the IT functionality? Am I looking at all the business units? You're describing exactly what you're covering in the scope of that document. Who is going to be in your recovery team? What are their qualifications? What are they going to deal with? What are their roles? How are you going to prepare for disaster? What the emergency procedures would be? And of course, how would I recover from that? What would my restoration procedures be? So yeah, so you would look at the sequence in restoring systems. So that's basically the order. Which system should have priority and be restored before other systems, and what should be done if a disaster makes the current location for processing data no longer available. So an alternative processing site has to be identified. And failback is the process of resynchronizing data back to the primary location. So basically, in terms of your disaster recovery plan, you have to test. Disaster exercises are designed to test the effectiveness of the disaster recovery plan. You're testing the efficiency of it. You're testing the procedures and determining your response strengths and weaknesses. Tabletop exercises simulate an emergency situation in basically a stress-free environment. So basically, if I have to look at lowest common denominator, it would be like a fire drill that you would have in school. It's in a sort of stress-free time. We know it's a fire drill, so we're not all that stressed. So that would be an example of a disaster recovery plan. Yeah, and of course, an after-action report is generated after this. So yes. In your disaster recovery plan, you're looking at who are the participants that are going to be involved on the decision-making level. You're going to focus on training your disaster recovery team in an informal setting, of course, discussed by a facilitator. The facilitator, by the way, can be somebody from your disaster recovery team. Yeah, you're going to identify problems as a group. And basically, the advantage of all of this could be can acquaint key personnel with emergency responsibilities. The disadvantage is the lack of realization. It doesn't prove a true test. And this basically means that when a disaster actually happens, people are going to act very much different to how they say they are going to act. And I mean this because we are in a more stressful situation when a disaster actually does occur. So it's not a true test of the procedures that you've put into place. Fault tolerance through redundancy. Now, these are concepts that maybe you guys have gone through in NWEG or maybe not. And basically, fault tolerance refers to a system's ability to deal with malfunctions. So we always try and build robust systems that basically are fault tolerant. And basically, the solution to fault tolerance is built-in redundancy. And this is the use of a duplicated environment or equipment to improve the availability of a system. So the goal is to reduce a variable known as mean time to recover. And this is the average amount of time that it'll take a device to recover from a failure that is not a terminal failure. And redundancy planning applies to servers, storage networks, power sites, and data. So of course, we all have servers in our companies. They play a key role in network infrastructure, and failure can have significant business impact. We want to combine 2 or more devices to appear as a single unit, and we also have server clusters. The thing about servers is you can actually have a lot of duplication on them, especially if you have intrusion detection systems and stuff. They would have a log of all your activity, which is useful. Yeah, all servers do useful work in a symmetric server cluster. If one server fails, remaining servers take on the failed server's work, and it's most cost effective, I would say. Asymmetric servers are used for databases, messaging systems, file and print systems, and yeah, both are pretty I would say well known or well used, definitely. Storage, well, solid state drives are used very often. They are more resistant to failure and more reliable than traditional hard disk drives. Hard disk drives are often first components to fail, and some companies keep spare hard drives on hand. Mean time between failures measures the average time until a component fails and must be replaced, and can be determined by the number of spare hard drives an organization should keep. Now, RAID, or redundant array of independent drives, uses multiple hard disk drives to increase reliability and performance. And it can be implemented through hardware or software. Several levels of RAID exist. So I want to actually show you guys a diagram which actually shows all of RAID in one picture. So RAID 0 uses a stripped disk array so that data is broken down into blocks, and each block is written to a separate disk drive. Minimum number of drives needed, 2, and your typical application is video production and editing. Advantages: simple to design, easy to implement, and the disadvantages: it's not fault tolerant, which is what we want. RAID 1, written twice to separate drives. Type of applications, you could use it in financial applications. Simplest RAID is RAID to implement. It can slow down the system though if RAID controlling software is used instead of hardware. RAID 5, each data block is written on a data disk, and partition for blocks in the same rank is generated and recorded on a separate disk. So you'd use this for databases. It's the most reliable. It can be difficult to rebuild though if a disk fails. And RAID 0+1, a mirrored array with segments that are RAID 0 arrays. So this is used in image applications. It's very expensive and has high input and output rates. Networks. So maybe necessary due to critical nature for connectivity today. So usually with networks, we do a replication scheme to keep the live network information current and launch automatically in the event of a disaster. So you have a second network, if you like. Power. Yes, that's our main issue, guys, power. So how do we maintain power? Well, VC does it very well. So when we used to have load shedding, well, I think we still, I shouldn't say when we used to have load shedding because I think load shedding is a thing that always pretty much happens. In terms of load shedding, they have an uninterruptible power supply. So you'd see with VC, the second load shedding happens, some things may go off, and then the generator kicks in, and we've got power, which is amazing. So uninterruptible power supply, amazing, maintains power to equipment in the event of an interruption in primary power. Offline UPS, less expensive, a simple solution, charged by the main power supply, begins supplying power quickly, but when primary power is interrupted, but also switches back to standby mode when power is restored. Online UPS, always running off a battery while the main power runs battery charger. It's not affected by dips or sags in voltage, and it can serve as a surge protector. UPS systems can communicate with the network operating system to ensure orderly shutdown occurs, but can only supply power for a very limited time. The backup generators generally are powered by diesel, natural gas, or propane. Yes, these are all things that we need to know as security experts. Recovery sites. Now, recovery sites is where do you go if a recovery to recover from a failure, from either a hack, either from a natural, either from an issue where you can't work at your primary base anymore, but you need to keep the system running. So there's three types of sites. There's a hot site. So generally, you'd use a hot site if, for example, your operation goes down, and you would have another setup with all your equipment, all your backups, everything is ready. You can just walk in and basically start business again. So that's a hot site, right? Your cold site provides you with the office space, but there's no backups that are immediately available. And it takes longer to resume full operation because you need to still install equipment to continue operations. So of course, it takes a lot longer, okay? So that's our cold sites. And our warm site, the equipment is installed, but there's no active internet or telecommunication facilities, no current backups. It's less expensive than a hot site, and time to turn on connections and install backups can be half a day or more. So it all works in terms of timing. Your hot site, you can pretty much resume immediately. Your warm site, you'd have to wait a day or, well, half a day or more. And your cold site, a little bit longer than that. So that's recovery sites, and of course, they are some more expensive than others. Hot sites being the most expensive, warm sites being a little cheaper, and cold sites being the cheapest option. Data backup is copying information on a different medium and storing it to an off-site location. And this is used in the event of a disaster. So you don't want all your information in one place. In other words, you store all your information on a USB or a hard drive. You don't want to keep it in the same building. You would want to move it to somewhere else with your backups. And the reason for this is, of course, if anything happens to the main site, you've still got your information, which is the most important. So two elements are used in the calculation of when backups should be performed, and this is recovery point objective and recovery time objective. Recovery point objective is maximum length of time organizations can tolerate between backups, and recovery time objective is length of time it will take to recover the backed up data, which they wonderfully have in this diagram here. There are full backups, differential backups, and incremental backups. Full backups, you are backing up everything, right? So this is what you would do when you first start backing up. Differential, back up any data that has been changed since the last 4 backups, right? And incremental backs up any data that has been changed since the last 4 backup or last incremental backup. So, yeah. So the most comprehensive backup technology is known as continuous data protection, and it performs continuous backups that can be restored immediately. And it maintains historical record of all the changes made to the data, which is of course very important. And it creates a snapshot of a data like a reference marker. Off-site backups means that I need to take all my backup mediums, that is like my USB, my external hard drive and everything, and put it somewhere else. But nowadays we have cloud technology. So the beautiful thing is we can back up all our information to the cloud and it's sitting on a server somewhere else. Of course, if we want to get really pedantic, this also means that if that server goes down, we don't have our information. So it's good to do a few types of backups. Backups on actual storage mediums, your external hard drives or your USBs, and do a cloud-based backup as well. Okay. So there's legal implications of offsite backups, and the primary issue involves data sovereignty. So data stored in a digital format is subject to the laws of the country in which the storage facility resides. So our organizations need to identify cloud service provider whose data center locations ensure that it fully complies with all applicable data sovereignty laws. We've also got environmental controls because, guys, computers are sensitive things. We have to think about fire suppression, electromagnetic disruption protection, and proper configuration of HVAC systems, as they call them. So fire suppression includes the attempts to reduce the impact of fire. So requirements for fire to occur is combustible material, sufficient oxygen to sustain the combustion, enough heat to raise material to its ignition temperature, and chemical reaction is, of course, the fire itself. So in a server closet or room that contains computer equipment, a stationary fire suppression system is recommended. And yeah, we of course need that. Electromagnetic interference basically is caused by a short duration burst of energy by the source called the electromagnetic pulse. Electromagnetic compatibility reduces or eliminates unintentional generation, spread, and reception of electromagnetic energy. And the goal of EMC is the correct operation of different types of equipment that function in the same electromagnetic environments. You also got these Faraday cages, which is a metal enclosure that prevents entry or escape of electromagnetic fields. And they are used often in electronic labs, and that's what they look like, basically. HVAC is heating, ventilation, and air conditioning systems. All have to maintain temperature and relative humidity at the required levels, okay? Because our computer systems react to the external temperatures. So yeah, I don't really have to, I think, go into detail with that. Of course, your server rooms have to be cool. Precise cooling is needed in some cases. Incident response is when an unauthorized incident occurs. So when an unauthorized person accesses a building, when somebody hacks your system, an immediate response is required. And incident response involves using forensics and proper incident response procedures. So forensic science, applying science to legal questions, and it's analyzing evidence that can be applied to technology. And computer forensics, which is actually a very interesting field, uses technology to search for computer evidence of a crime. So basically your digital footprint. So guys, when you are browsing and you want to browse for things you don't want anybody to maybe know about, how do you do that? I know we're all good people.
VPN.
VPN, yes. Who uses incognito browsers? Huh? Who browses incognito? Anybody? Oh, nobody. Oh, we got nothing to hide.
I do use it,
Sorry?
but only for like I use it when I'm going for like flights and
Yes.
hotel, like looking up. So then they
Mm-hmm.
don't use the cash and bump up the price or something.
Yeah, I understand. Yeah, that's a good idea, actually. That taught me something new today, yes. So, of course, you would know that analyzing computer resources can obviously implicate people in big ways because you can find a lot of digital evidence, especially on your hard disk drives. Yeah, so of course, in terms of your incident response plans, it's a set of written instructions for reacting to a security incident. And they actually give you the 6 steps: preparation, identification, containment, eradication, recovery, and lessons learned. So at a minimum, an incident recovery plan should include the following: documented incident definitions, cyber incident response teams, reporting requirements escalation, and of course, exercises. So your 5 basic steps: securing the crime scene, preserving the evidence, establish the chain of custody, examine evidence, and enable recovery. So when something illegal or unauthorized occurs, action must be taken immediately. So what do? Individuals in the immediate vicinity should perform damage control, report the incident to security or police, confront any suspects if the situation allows. But I think if somebody's waving a gun, nobody's going to confront the suspect, which makes sense. The most safe thing to do anyway. Neutralize the suspected perpetrator from harming others. Yeah, sorry that I'm laughing about this. It's just very crazy scenario this would be. Secure physical security features, quarantine electronic equipment, and contact cyber incident response team. So of course it depends on the actual incident that occurs, right? There would be sets of rules that you would have to follow. Now, whichever company you're in are going to lay those rules out for you. You're going to end up reading entirely huge booklets and policies in your lives, unfortunately, at pretty much every job you go to. You'll be getting one on disaster recovery, and you're going to definitely get one on ethics. That's going to be the 2 policies they're going to make you read. After the response team arrives, the first job is to secure the crime scene, and that is your physical surroundings. They'll take photographs. You make sure your computer cables are labeled, or they will label it. Team takes custody of entire computer. If it obviously depends on the crime. Team interviews witnesses, and after a length of time is the incident of course should be noted or documented. Preservation of evidence, ensuring that important proof is not destroyed. Digital evidence, we know, is very fragile. It's easily altered, it's easily destroyed. Somebody can easily destroy a USB, throw it away, reformat it. It's not so difficult. So one of the first steps is for a legal hold to be issued. So it's a notification sent from the legal team to employees instructing them not to delete electronically stored or paper documents related to the incident. Cybercrime incidents captures volatile data, so contents of RAM, current network connections, logon sessions, network traffic, and logs. So that's basically what they mean. They tell you exactly what they want in terms of detail to be retrieved. Your register, your peripheral memory first, then your random access memory, then your network state, then your running processes. So use tools that allow capturing a system image. So a snapshot of the current state of the computer that contains all the settings and data, and capture the image on the screen by taking a screenshot. So this is basically, all of this is evidence, or how to basically gather your evidence. Chain of custody are documents that evidence was maintained under strict control at all times, and no unauthorized person was given opportunity to corrupt the evidence. After computer forensics experts create a mirror image of a system, the original system is secured and the mirror image is examined to reveal evidence. So this includes searching Word documents, emails, spreadsheets, and of course the cache and cookies and the web browser. And hidden clues can also be exposed by looking at RAM slack, driver slack, and metadata. So to enable recovery, we need strategic intelligence, which is the collection of processing, analyzing, and disseminating intelligence for forming policy changes. Strategic counterintelligence involves gaining information about the attacker's intelligent collection activities, which is basically how they would have got into your system. What malware did they use? How did they infiltrate your system, etc. And of course, activity logging, which is maintaining active logs regarding all the activities conducted by the attacker, including if you can manage to get them on camera dumpster diving, that would be very useful. So yeah, as I said, that's basically chapter 14, guys. And the reason it's gone so quick is because the terms are very, very self-explanatory. So you would notice this with chapter 15 as well. So basically we're talking about continuing business, which we spoke about, sorry. And now we're talking about the risk and how we manage risks. So we think about the risks before we actually implement the system. Because you wouldn't basically, let's take an example of this. If you bought, if you were crazy enough, no, I shouldn't say crazy enough, we IT people. If you bought a laptop for 50,000 rands, what would you do first?
Install GTA 5.
First thing you would do is you would insure it. Because what is the inherent risk? With laptops, it's physical theft. With the cell phone, it's physical theft. So depending of course on how pricey your equipment is, you would insure it, because there is the big risk of theft, right? So risk is an undesirable effect, undesirable event that can occur to some, and basically it's involves some type of danger. So in terms of managing risk, you have to create a level of protection that minimizes the vulnerabilities to threats and reduces potential consequences. So you need to assess the risks and know what threats you are actually facing. So when you do a threat assessment, it's a formal process of examining the seriousness of a potential threat, as well as the likelihood that that threat can actually happen. So there's three types of threats: man-made and internal versus external. So in terms of your threat assessment, you've got your threat category, which is strategic, and they describe this as action that affects the long-term goals of an organization. And that is threats of stealing information, loss of major accounts, competitors entering the market. Your other threats are compliance, and that is following or not following a regulation or standard. So breach of contract, not responding to laws, that's compliance. Financial, impact of financial decisions or market factors. Okay, that is like increase in interest rates, global financial crisis, etc. Operations, events that impact the daily business of an organization, and these, of course, the things that can affect these are fire, hazardous chemical spills, blackouts. All of those would be operational. Technical are things that's going to affect the information technology. So your denial of service attacks, your viruses, your ransomware, etc. Managerial, actions related to the management of an organization. So of course, maybe long-term illness of the company president or key employees resigning. So threat assessments have to determine what the asset values are and relative worth of an asset that is a risk. So if we have to look at supply chain assessment, a supply chain basically is a network that moves a product from the supplier to the customer and should be viewed as assets to the enterprise, and threats need to be cataloged. Assessing threats is not straightforward, and that's because there's just so many of them, and we have to then categorize them into what would be most harmful for us and what would be least harmful for us. We can't protect against every single risk out there. Okay, it's not even possible. Risk assessment involves testing, change management, privilege management, incident management, risk calculations, and representing risk information. So Technology assets should be tested to identify any vulnerabilities. So this involves your hardware and your software. Your intrusive vulnerability scans attempts to actually penetrate the system to perform a simulated attack. So this is when you get an ethical hacker to come in and try and break your system. Well, not necessarily break, but try to break into your system. Non-intrusive vulnerability scan uses only available information to hypothesize the status of a vulnerability. And of course, your penetration tests are designed to exploit any weaknesses in the systems that are vulnerable. So penetration testing authorization should be obtained. So reasons that this authorization should be obtained are you need legal authorization, indemnification, and limit retaliation. Change management. This is when you make modifications and keeping track of changes. So it ensures proper documentation of changes occur, so future changes have less chance of creating a vulnerability. And what I mean by this, or what I mean when I'm talking about change management, is any software that you're thinking about has a vulnerability inherent in it. No system is 100% secure. So when I'm talking about change management, what happens here is, let's say I want to add a feature to my software. So for example, I want to add a chat facility to my software. Would adding this chat facility make my system more vulnerable, because me coding up this chat facility is going to leave a loose end? Now, most of your applications go through your change management processes. I mean, if you look at any app, WhatsApp, how it's basically added more features, it's added stickers, GIFs, video calling, voice calling. They do a lot of upgrades, and these upgrades involve change management. And when they're doing their upgrades, they have to realize that, okay, once I've added something, have I not left something else vulnerable? Okay, so two major types of change for documentation: changes to the architecture of the system, and this basically refers to your whole system infrastructure, or changes to a file or document classification. You also have your change management team involved, and this is the body responsible for overseeing changes that you make to your software. It's composed of representatives from all areas of IT, network security, and upper management, and proposed changes have to be made by your CMT. And their duties are to review the changes, ensure risk and impact of planned changes is understood, and of course they recommend approval from the board, and they communicate these proposed changes to co-workers. Privilege, we talked about it, I think, in the last lecture, or the lecture before that. Subjects access level over an object, such as a file. Privilege management, a process of assigning and revoking privileges to objects. And privilege auditing is periodically reviewing subjects' privileges over an object. So basically your access rights. Incident responses. Basically, this deals with the components required to identify, analyze, and contain an incident. Incident handling, planning, coordination, communications, and planning functions needed to resolve an incident. And incident management is the framework and functions required to enable incident response and incident handling within an organization. And we use this to restore normal operations as quickly as possible with least impact to businesses or users. So how do we calculate risk? Well, there's many ways to do this. The qualitative risk calculation uses an educated guess based on observation. So you typically assign a numeric value on a scale of 1 to 10, being high, medium, or low. That represents the risk. Quantitative attempts to create hard numbers associated with the risk by using historical data. And it's divided into the likelihood of the risk and the impact of the risk being successful. So we use these quantitative tools to look at the likelihood of risk. That is mean time between failure, mean time to recover, mean time to failure, and failure in time. And historical data can be used to determine the likelihood of a risk occurring within a year. And this is known as annualized rate of occurrence, which is quite popular. So who uses calculations? Your police department for crime statistics, insurance companies, and of course nowadays pretty much every company, because computer incident monitoring organizations, as well as your own companies, any company would do a risk analysis, right? Because they would want to know the risk impact. So you compare the monetary loss associated with an asset in order to determine the amount of money that would be if the risk occurred. So how do we do this? We use two calculation formulas: single loss expectancy, expected monetary loss every time a risk occurs, or what would be the annual loss if this risk did occur. So representing risks, we can use a risk register where we list all the potential threats, their risks, and we label them as high, medium, or low. Or we use a visual color code that looks at the impact and likelihood of risks. Yeah, red being bad. Approaches of reducing risk. How do we reduce this? Well, there's many ways. We use control types, distribute allocations, or implement automation. So when we use control types, we use security controls. So we can use administrative controls, processes for developing and ensuring that policies and procedures are carried out, or technical controls. And these are security controls carried out or managed by devices. And we've seen a lot of these in the duration of this course. They could be physical security controls like your gates, fences, access control mechanisms, your biometric controls, and of course your login usernames and passwords. Your password policy would be part of a technical control because maybe they want users to have hard to guess passwords. Subtypes of controls that can either be technical or administrative, deterrent, preventative. We've done pretty much all of these in the duration of this course. Controls, of course, deters a risk from occurring. Preventative prevents it from occurring altogether. Physical controls, how do we physically control the risk of unauthorized people perhaps getting into a building? Detective controls, how can we detect risks and hopefully be in time to prevent them? Compensating controls, how do we compensate our clients if their information is stolen and their credit cards are used? That would be how would our plan for compensating. And corrective controls, how can we then recover from this risk? So yeah, distributing allocation. Distributed allocation is spreading the risk. So there's three ways we can do this. One way is transference, and this makes a third party responsible for your risk. So this is an example of this would be taking insurance on something. So taking car insurance. So then if your car is stolen, you get paid out to get another car. Or if your car is damaged, insurance will pay for the damages. Risk avoidance involves identifying the risk and making the decision to not engage in the activity. So this is more like denial. Okay, the risk is there, but I'm going to try to just avoid it. Okay. This is the cheapest strategy, by the way. And mitigation is the attempt to address the risk by making it less serious. So you take some measures to control the risk, but not huge ones, I would say. You try and minimize the risk, but you're not trying to prevent it, or you're not preventing it, you're trying to reduce it in some way. Risk is introduced through human error. Using technology as a strategy for reducing risk can minimize these errors. And we do this in three ways: automation, images and templates, and our non-persistent tools. So automation can be defined as what replaces human physical activity. So using technology to automate IT processes, and automation can provide scalability, the ability to continue to function as the size or volume of the enterprise data center expands. So basically this means that your server is not going to go down because you've got more and more users. Elasticity, the ability to revert to the former size after expanding, so flexible. Continuous monitoring, sustained and continual surveillance. Secure configuration guides help IT security personnel configure hardware devices and software to repel attacks. You've got vendor-specific guidelines if you have bought software from somewhere for configuring web servers, etc. And also review the configuration of systems to determine if security settings are correct. Master image, the copy of a properly configured and secured computer software system that can be replicated to other computers. Eliminate the need for configuring individualized security settings. Now, this is what they use in the LANs, an image. So they'd have one image that's configured and they use it pretty much on all the computers instead of doing it piece by piece. Template, a type of document in which the standardized content has already been created. A user only needs to enter specialized variable components, and this reduces the amount of data to be entered and helps minimize errors that could then introduce a risk. Non-persistent tools are used to ensure that unwanted data is not carried forward. So there's quite a few ways of doing it. Live boot media is one of them. So it temporarily creates a secure, non-persistent client for use on a public computer. Revert to a known state, so restore to a previous condition that was secure. Roll back to a known configuration, or snapshots, and this is basically used to replace a corrupted or infected virtual machine. Practicing for reducing risks. Well, the main thing is security policies. All of us have a security policy. Even Varsity College has a security policy, which is in your guys' code of conduct. Your security policy, you need to train users as well. So you need them to have awareness and training so that they do not fall for phishing attacks, etc. It could be, more diverse than what I've just said. Agreements and personnel management. In terms of security policies, it basically communicates a consensus of judgment, and it defines appropriate behavior for users of a system. It identifies what tools and procedures are needed, and it provides directives for HR action in response to inappropriate behavior. So it, of course, helps to prosecute violators if necessary. So this is a written document. It states how an organization plans to protect the company's information technology assets, and it outlines the protections that should be enacted to ensure the organization's assets face minimal risk. So having a written security policy empowers an organization to take appropriate action to safeguard its data. And the functions of a security policy is the overall intention and direction formally expressed by by organization's management, and it provides details on specific risks and how you would address them, provides controls to reduce the risks and help direct employee behavior, help create secure, aware organization culture, and helps ensure employee behavior is directed and monitored in compliance with security requirements. So what is a security policy? An effective security policy must balance trust and control. And there's three approaches to trust. Trust everyone all of the time. Trust no one at any time. Trust some people some of the time. So security policies attempt to provide the right amount of trust. Trust some people some of the time. and builds trust over time. So level of control must be balanced and influenced by security needs and, of course, the organization's culture, which is a big one. Security policy must be comprehensive and detailed, and an example of this would be an antivirus policy, the email policy, your login and password policy. You could have a page just on a password policy, and that is the password should be alphanumeric, it should have a special character, it should be changed every 21 days. If in the event you as a student leave varsity college, what would be the situation? You could access your account for maybe 1 month after you leave. All of these in a policy. So yeah, acceptable use policy is a policy that defines actions users may perform in accessing systems. So these users are employees, students, vendors, contractors, visitors, yeah. And it covers all computer use, including mobile devices. So unacceptable use may be outlined and are generally considered the most important for security policy. So there may be some websites that users are not allowed to go on, and that would be explicitly stated in that security policy. So personal email policy generally covers 3 important elements: using company email to send personal email addresses. So depending on your company, this could either be acceptable or not. As I say, it depends on the policy of your actual company. Accessing personal email at the place of employment. So again, it depends on whether the employees are cool with that or not. And forwarding company emails to a personal account, there could be a policy against that. Social media policies, there's huge social media policies. In fact, we all get one when we get employed. And basically, can you access social media at work during using the company resources? It, as I said again, depends on your company. Of course, we know there are risks involved where your data can be used maliciously, users are too trusting. Yeah, accepting friends may have unforeseen consequences. Yeah. So yeah, again, social media, it basically the policy would outline whether it's accepted for you to use it or not. Yeah. As I say, a lot of this would depend on your company. Awareness and training. Now, we don't do enough of this. So this is a key defense in information security, is the user awareness, providing awareness and training to users. And all users need continuous training in new security defenses because there's always new attacks. So when you basically are hiring somebody, you should provide security training. After a computer attack has occurred, definitely you should definitely provide security training then. When an employee is promoted to a position where they have more access, you should provide training there as well. During an annual department retreat, yeah, have a speaker come in and talk about security and how they can be more vigilant when new software is installed or when new hardware is upgraded. So yeah, in terms of our awareness and training, they talk about basically how you would teach each subject in terms of the approach you would use. Yeah, so basically, if we think of teaching a student, it would be very different for us to teaching an employee. And we also have to consider how people like to learn, their different styles. So you guys have everybody has a different style that they like. Some people like visual, right? So they respond better to pictures than to text. Auditory, people like to listen, right? And kinesthetic, people like to do. So for example, with programming, you are doing. So you are more involved in the process. So yeah, you have to think of how people like to learn. There's also role-based training, which involves specialized training that is custom to a specific role that the employee holds in the organization. So you teach the employee basically how to fulfill their role. And this basically happens a lot when you're taking over from somebody. Agreements, risks of third-party integration. So basically, this is if you employ a third party to take on some of your risk, you have to think of onboarding and offboarding. In other words, how you are going to get, when employees join, right, what would be their procedures? And of course, when they resign, how do you offboard them? Application and social media network sharing. Yeah, you've got to think about what the policy would be with relation to this within your organization. Privacy and risk awareness training would be important for your new person coming in, for sure. And data considerations. How much of your data is cached? What do you search for when you're at work that you might not want to? Because please note, guys, a lot of your activity is logged. Interoperability agreements is formal contractual relationships as they are related to security policies and procedures. And these are part of standard operating procedures or those actions and conduct that are considered normal. And we've got service level agreement in either. Your blanket purchase agreement is a prearranged purchase of a sale between a government agency and a business. Memorandum of understanding describes an agreement between two or more parties. Interconnection security agreement, an agreement that is intended to minimize security risks for data transmitted across a network. Non-disclosure agreement, a legal contract that specifies how confidential material will be shared between parties but are restricted to others. Okay, of course, when you hire someone, a background check has to be coordinated. So this is the process of authenticating the information supplied to a potential employer by a job applicant in the applicant's CV. And when an employee leaves, an exit interview is usually conducted. And this is a wrap-up meeting between management and representatives and the person leaving the organization. Okay, troubleshooting common security issues. Security professionals should have knowledge and skill to troubleshoot common issues, including access violations, asset management, authentication issues, baseline deviation, certificate issues, data exfiltration, etc. So these are the fields that a security professional should know. And security professionals should have knowledge and skill to troubleshoot common issues, unauthorized software, unencrypted credentials. I think just as a developer, these are things you should know anyway. I don't think this is just security professionals. As a developer, you are going to be hopefully developing software that is secure and does have security coded within it. That is very, very important, which we will get to in third year. So yeah, that's basically risk management, guys, and that is learning unit 8. So yes, I know it's a lot of information that I've given you guys in this very short amount of time, but yeah, any questions? Comments, queries, complaints? Are we all good?